So what we're going to do is, this is the Doppler effect. You've just watched the clips. Okay, and this is the definition of it. It's the apparent change in frequency. Remember, frequencies are high or low the note field sounds, okay, of a wave due to the movement of the source of the wave. Okay, so the source. So in other words, this is a car making noise coming towards you. The frequency would be higher than if it was going away from you. Okay, the formula, which looks a bit intimidating, but you'll have no problem with it, is this: F dash, that's F dash, is FC over C plus or minus U. We'll worry about the plus and the minus in a minute. Remember, you have no worries about that. You use a formula all the time in algebra, in maths. Minus B plus or minus, you know, so that's really two formulas in one, as we'll see in a minute. F dash is the apparent frequency, so that's the frequency you hear. It's coming towards you, going away. F is the actual frequency, if it was stopped. C is the speed of the wave, and we're always going to be doing sound, so that'll always be 340. And U is the speed of the source, okay, which, like the car or whatever, okay. Now, this is something you must remember. If the source is coming towards you, now it'll be a higher pitch, a higher frequency, so that this, instead of the plus or minus here, you just put in the minus, because this number you want to be bigger, okay, and if you make the denominator smaller, the number will be bigger. The way and if it's going away, it's plus. The way we always remember this in Leaving Cert is, if you think of the Gardaí are coming to get you, okay, and the sirens are blaring and they're coming towards you, okay, that's very negative as they come towards you. It's negative, so they're coming towards you, and you put in minus for negative. But then, as it turns out, they weren't looking for you at all, and they drive past you, okay, and you breathe a sigh of relief. They're going away from you, and that's positive. So if the source is coming towards you, it's negative, because you think they're going to arrest you, but then they go past you, it's going away from you, it's positive, and you're happy. Okay, so that's one way of remembering the two of those, right? So let's look at question one. Okay, I'm going to just do one question, and I'm going to give you two then, one coming towards, one going away, and we'll see how you get on with it. Calculate the apparent frequency if a source of a wave of frequency. Okay, so ask for the apparent frequency, and you look up here, that's F dash. So we don't know that, so that's your question mark. If the source of the wave of frequency 500 hertz, so the actual frequency is 500, so you write this down, you make your list, that's the way we always do it, is approaching you at a speed of 10 meters per second. Now that's the speed of the source. Okay, so U is 10. The speed of sound in air, and that's the speed of the wave, and that shows up twice in the formula, so that's 340. Okay? If you're doing Leaving Cert Physics, you'd have to decide which formula you're going to use. Here, it's obvious. Okay, it's the Doppler effect formula. It's pretty obvious in Leaving Cert Physics too. Okay, it's a standalone question, so you write it down. Let's have a look. We're looking for F dash. We need everything else. Do we have F? Yes. Do we have C? Yes. Do we have C again? Same C. Happy days. Do we have U? Yes. So we just fill it in. So F dash equals F is 500 by C, 340. Sorry, I should have fixed that. 340. It was coming towards you, so the formula we would have used, that was a negative experience for the Gardaí coming at you, so it's minus, so 340 minus 10. Okay, your calculator now will do the rest for you. Okay, so just use your A over B. So we have 500 multiplied by 340 over 340 minus 10, and as you've seen earlier, okay, if it's coming towards you, the frequency will be higher, and it's working out as planned, 515.2 hertz. And that's it, and that's what you will be doing. Okay, now you have to decide in the plus or minus. That's the important bit. Okay, I'm going to give you two basic questions on that to practice now. Okay, and we'll have a look at more of them on Friday then. Okay, as a secondary point, remember the formula that we looked at the last day. V is frequency times wavelength. Okay, let's just do a question on this. It's a very basic question. Okay, so the speed of a wave is 4 meters per second. Okay, the wavelength is okay, I'll make it interesting here now. 20 centimeters. Calculate the frequency. There's a little bit of extra here now just to watch. Okay, so the speed is 4, so V is 4. Okay, the wavelength is 20 centimeters. Now you always have to change everything to meters. So you change that to 0.2. And the frequency we don't know. So using this formula, V is F times lambda. Lambda, remember, is a wavelength. Okay, I wrote that in there. So 4 equals F times 0.2. Only one unknown. So by both sides by 0.2 or bring it across, whichever way you do it in your maths, and you get an F of 20. And remember, frequency is hertz. Okay, so I'm going to give you one of these. I'm going to give you two of these. Okay, and you're going to do those once you get the chance, and just send in the assignment as soon as you've done this afternoon. All right.